Hey everybody, and welcome to another JASP video. In this video, we're going to explore a new package, probably released in the last 6 months to a year or so. It's been a while since I've explored all of the packages and stuff. So I am using version 2.644, 2.6.44. This is the current macOS version that has all features, so it's the most up-to-date version that you can find on their website. And we are going to explore the SaRa module. So how you find, download and find SaRa. Well, here it is on my list because I've already downloaded it, but let's go to Manage Installed, and let's just type in SaRa up here in the search bar. And here it is, SaRa, with the R capitalized for R, the statistical language, or the coding language. SaRa, Statistical Analysis with R, add-in for Jamovi, developed by SaRa Marti and David Leiva. An R package for a basic course on statistics in Jamovi. So if you're teaching statistics, this would be a great one. If you're learning statistics on your own, this would also be a useful thing. There are so many different statistical packages out there. We're just going to do an overview of it. Basically based on the JMV package. The JMV package is the base R package that Jamovi uses to do these exploration, t-tests, ANOVA, frequencies, all of the stuff that you get when you download Jamovi at the start, right? And without putting in any other packages, that's the JMV package, right? The add-in includes a suite of univariate and bivariate descriptive methods for nominal, ordinal, numeric variables. Numeric, I assume they're referring to interval and ratio scale variables. The scale variables, the indicated by a ruler, right? So these are nominal variables, right? The add-in also incorporates a module of probability distribution. Pretty cool. Continuous and discrete. Well, we'll take a look at that for a statistics course. Package primarily thought and developed to be usable within Jamovi statistical spreadsheet. See for more information. They probably wanted to put a link here. I'm sure we could find SaRa online. Maybe I'll grab a webpage and see if we can look for it at the end of this video. So I opened up book sales. You can find book sales in the LSJ data. You can download this through the modules thing right here. LSJ data, it's just a sample of data for a companion book. So I just opened up book sales because it's got a few different variables. SaRa does not necessarily need where are you, SaRa? You're on here somewhere. There you are. So SaRa's right here. So we've got 4 categories of statistical techniques. We've got probability, so we'll go through discrete and continuous distributions and the kind of options that you can get from there. Your univariate analysis, so this would be one dependent variable, categorical, ordinal, and numerical. Bivariate analysis, so 2 variables, okay? Categorical, ordinal, numerical, and then you can have mixed, and then some miscellany, a Mann-Whitney U-test, a Wilcoxon non-parametric t-test, and some normality tests, which normality tests kind of you can get from other places in Jamovi. So again, this is a complementary module, and one that you can pair with a statistics textbook if it uses SPSS for reasons. I'll give you an example. I used Salkin's 7th edition statistics for people who think they hate statistics, right? I use that one, and it uses SPSS. And you get a bunch of SAV files, which can be open here in Jamovi, which is great, but you have to be able to translate the SPSS processes into JASP, and here you can develop your own. So let's kind of look through it. This isn't a tutorial on how to do each of these things. I want to make that clear right now. We're just going to look over it. This is an overview video as opposed to a straight up go through each option and explain each option and the output. So let's take a look at what we can do with discrete here, okay? Discrete distributions. So discrete distributions are going to be based on a set number of outcomes, right? So for example, a binomial distribution is perhaps the most common of discrete distributions, but then we have the Poisson, and so you can do that one, or you can do a negative binomial. Okay, so right now binomial is the one that is chosen. You can also do geometric and hypergeometric. So these are the 5 discrete distributions that you can do. So by default, you get these values for binomial. Number of trials is 10, and the probability of chance is 0.5. So the default here is a coin flip, right? Heads or tails. So in our output, without looking at anything else, we have the parameters, n10, p of 0.05, right? And the probability for x equal to 0 is a very small number. X is equal to our 0 value, very, very small number. And the quantity is 5 and 5 in each tail because it's half and half, right? So we can change that. We can change this to, 0.33. Oops, too many points. That's, all right. It didn't like what I was doing. There we go. 0.33, right? And so the probability of x being equal to 0 is a larger number than before. And then we have 3 in each tail because that makes sense. If you've got 10 trials, 3 is going to be in the left, 3 is going to be in the right, and 3 is going to be 3 or 4 is going to be in the middle, I guess. You can change these outputs. We can get the cumulative distribution function. We can get the survival, right? There's p is x is greater than x. So that's the 1 minus value there, right? So you can go through all of that and you can get plots. Okay. Actually, I'm going to change this back to 0.5 so you can see what that looks like. So here we go. Here's the probability. You've got 5 over here and 5 over here. That, and then you can do the cumulative distribution function, which looks, I guess, about the same. Survival function, which is just -1, right? You can get additional ones. You can set what values, right? That would be useful if you're doing all sorts of in-depth things on discrete distributions. But let's take a look at continuous distributions, because those are a lot more fun, right? Mean and standard deviation. Here's your 0 and 1. This is what I would be using in my class. I don't spend a lot of time on discrete functions, right? And the fact that they're discrete is that we've got blocks. This is like a histogram, right? But if we do continuous functions and we plot our density function, look at that. That's amazing. Wonderful, right? And it goes up to -4. Plus or -4, all right. But then we can get t distributions, and we can play around with that. We can get the chi-square distribution. We can get the f distribution, which sets it at 0. It's funny how it doesn't do it over at the y-axis, but that's all right. The mean of f is 1, right? We can get that one. Oh, well, let's change the numerator here to 25, and you can see that, oh boy, look at that. 1 of 25. We can get an exponential function. We can get the uniform function as well. And we can change the values. And we get over here, normal distribution. We can put our mean at 5 and our standard deviation at 2.5 and see what happens to there. Look at that. It just puts everything in a place for us. I love it. This is great. It's a little bit more comprehensive of a distributions analysis than some of the other distributions stuff. And I can't remember. There is a module here somewhere where you're like, oh, distraction, right? So if we compare, here is, you can see far fewer options, and it's a less pretty graph, right? So not to say that distraction isn't a bad module, but I'm just saying it's like a comparison, right? There you go. All right, let's go back to SaRa. So those are the distributions. Then we can use univariate analysis. We can get categorical data. Let's go scroll down here. Let's get categorical data for days, shall we? Okay, so just to remind you what days looks like, 31, 28. These are the amount of days in a month, as is tradition. Okay, there are only 3 options, February being the 1 month, right? And so you get frequencies and odds. You can get the mode. What's the mode? 31 days. Yeah, that is true. There are more months that end in 31 than 30 or 28. Let's see. And then you can get the BLAU. I actually don't know what the BLAU is. Somebody in the comments, please tell me what BLAU is. You can get the interqualitative variation. I actually don't know what that is either. So, comments down below, please, on what BLAU and IQV is. You get the variation ratio and the Teachman. I don't know what any of these statistics are except for the mode. So let me know. You can get a pie chart. Oh, look at that. Pie chart, 7 months with 31 days. Nice, right? Pareto plot. Okay, interesting. You can get a bar plot, which looks like the opposite of this. You can get the donut plot. Donut. Okay, donut is a outside pie chart. You can get a lollipop plot. Oh, it's this one. Okay, I like it. You can change percentages for the lollipop plot, though. Percentages or counts. And then for the bar plot, you can do counts or percentages as well. That's really cool. I like that. That's really cool. Okay, going to ordinal data. I don't really have any ordinal data. Let's do sales, sure. Cannot be treated. Let's see, month, can it be treated? No. I need something that is that. Okay, well, in any case, I don't have anything for it, so let's see. Can I change? What's the data look like? Sales? No, it's nominal. All right, well, oh well. We'll take it out there. I didn't realize that I wasn't going to be able to do it. But in any case, this is what you see in, your exploration, your descriptives, all of that jazz, right? You got your mean, median, mode. You got your tri-mean. So that's a new statistic if you needed one. Quartiles average. Okay, so the mean within the quartiles. The mid-range. So these 3 are atypical. So that is uncommon, rare to be referenced in any kind of literature, but they exist, Dispersion. Okay, so you get the range, you get the IQR, interquartile range, quartile deviation. So the standard deviation within a quartile. The median absolute deviation, or MAD. That's uncommon, but can be referenced sometimes in when discussing medians, right? So these would be if you have a true ordinal variable, and you might want to reference these kinds of variables when you use a Likert scale, you know what I mean? Robust coefficient of variation in a range, right? You can just get instead of interquartile range, you can specify how much of the data you want to do. Position, right? So what are the values at each of these quartiles, or any percentiles that you name? By default, the 3 quartiles are main, right? This is quartile 1 is a 25%, quartile 2 is 50, and quartile 3 is 75, right? So it's just that. You can get your skewness and kurtosis values, and then you can get your plots. So you get the bar plot, and you can change your frequencies to counts or percentages, and then you can get the lovely different box plots. You can get a box plot, you can get a violin, and you can put the data on either of these 2, whether they're jittered or how much they are jittered, which I think is pretty cool. Okay, moving on. Numerical data. Okay, we can put numerical data into variables here. Oh, cannot be treated as numeric. Well, I'll be the judge of that, because it is. Let's go back to universe. There we go. There we go. So interestingly, this module, not that I realized it, but it's a little bit more strict on matching the variable type here that this base descriptives module is not. So that's interesting to note. Statistics, a lot more statistics, right? We can get trimmed mean, Windsorized mean. We can get a lot more dispersion. We can get variance and standard deviation now, right? We can get, I wish there was a select all button. Oh yeah, look at that. Get it, get it. So it's basically, in addition to the ordinal analysis, you get all of these other ones, right? So we can get Pearson's beta, which is a skewness. Fisher's, I don't even know what character that is. H1, H3, Pearson's beta's 2, Pearson, kurtosis, all of those, plus, and then we can get histogram density with the normal curve. Oh boy. And the reason why this is the case is because, as you saw in the data, there's a lot of zeros. A lot of issues with book sales, I suppose. And then we can get our QQ plot, which is going to be very, over here, not normally distributed. And we can get the mean on there. We can add the mean. So we've got our box plot. We've got our violin showing us where everything is, right? With the mean, then the median, and I think this is an outlier maybe? Yeah. And then our QQ plot. Oh yeah, so it put all of the data on there jittered, and we can put that there. So we can uncheck mean. Interesting how it changes every time I keep clicking it. I don't know why it's doing that. It's changing the values every single time. I don't know if that's a bug or what. Huh. Mean of the keeps finding different means, Okay, so maybe it's because of the choosing the inner fence and the outer fence. Maybe that could be it. It's probably it, actually. All right, so that is all of the ways to mess around with SaRa and a single variable. But then we can do categorical variables, and we can do month by rows. So this would be a chi-square test, right? As you can see, it gives you chi-square and Kramer's. I don't know if there should be an accent over that E, but okay. Kramer's V, right? Because it's 2. It might not give you a value if you have a 3x3 or something like that. I can't remember exactly. But it also gives you prediction errors. So you get lambda, tau, and Thiel's U, which you don't get from the goodness of fit or association test. Well, actually, it would be the test of association or independence here. And you can get observed counts and rows. You can get a ton of stuff. Okay, so these are the Goodman-Kruskal lambda and tau. Okay, but you can get a whole ton of stuff. Kramer's V, Chuprov's index, Sakota's index, lots of stuff added in here. Oh, you can get a mosaic plot, a bar plot. Oh, so many different things in this, like wild. Lots of different data analysis. Okay, so SaRa, we can go to ordinal as well. Very similar. Oh, you can get a heat map and alluvial plot in addition here. I'm not entirely, these would be specifically ordinal. This would be an ordinal test of independence, I suppose. Although statistics, okay, so this would, I'm not familiar with any of these. Kendall's tau, I'm familiar with Kendall's tau, but A, B, and C, that's interesting. Okay, and then you can get, I'm assuming these are other statistics. Summers D, not familiar with that one. If you want to educate me in the comments, be my guest. Wilson Z, not heard of that either. Interesting. So much of statistics is unexplored from my perspective. You can do numerical data, which is, like t-tests, right? So Pearson's correlation, Spearman or Kendall's. You can get R squared up in here. Plots, scatter plot. Okay, so let me see. Yeah, it's not gonna let me do it. I don't have enough. Okay, well, I was gonna show you, but I'm not gonna add another variable just to show you. But I mean, you've seen scatter plots all over the place, right? It's just gonna do all of the association indices here, and you can get what you need to on the scatter plot. You can get the regression line, and you can get marginal densities, histogram, or you can put the box plot on the side of it. That's pretty cool. And then you can use mixed. So this is t-tests. So the previous one was for correlations to scale variables or interval ratio. This one is, group by stock levels, so t-test or ANOVA, I guess. And then we can go with sales, and we can get that, not a number in there at one point, right? So we can get all of the statistics from previously, but we can also get the Cohen's D. Well, there is no Cohen's D because that's 2 levels. We can get eta squared, right? So this isn't actually doing the inference test, right? This is just descriptive data. I want to be clear, right? So we can get a histogram, we can get the curves, we can get the QQ plot, box plot, violin, we can add that in, right? Here's high, low is only one value, and then out, right? And then we can plot the QQ plot just like this. So lots of different things to do. And then let's round it out by just showing you what these Mann-Whitney tests are. Okay, you get the U and the Z. This is, again, a t-test alternative. It's got all of the stuff that you would see in there. You can get confidence intervals. We can do the Wilcoxon T. Again, we can do that. And then normality tests, just to show you. The Shapiro-Wilk, or Wilk, is the default. You can get the Komolgorov-Smirnov, which you can get by adding the more tests module here somewhere. I've got it here, somewhere in here. Anyways, it's in there somewhere. But you can also get the Pearson chi-square test, the Anderson-Darling test, and a few others, right, to test normality. And then your QQ plot, which is found in a lot of places, also tests for normality, but you can get histograms to actually see whether or not it is normally distributed, just visually speaking. So there are lots of options here in SaRa. Oh, where did I lose you? SaRa. So that's, in a nutshell, the overview of the new SaRa module in Jamovi. It's a downloadable module that you can add to your Jamovi and have a more robust data exploration module with a few tests here and there, right? You can see that we've got some probability, we've got some single variable analysis, double variable analysis, and a few different non-parametric tests. If you have any comments, suggestions, questions, or other feedback, please leave that in the comment section down below. Thank you for watching this video, and I will see you in the next one. Bye.